All right. How do we find all the solutions to the equation? So in order to find the solutions to this equation, first notice that this is the product is going to be negative. That means our signs must be zero. Our signs must be different. So we have plus and a minus. What we need to do is find factors of 24 that when we subtract it, it will give us 5. Those factors are 8 times 3. One of these must be negative, so we'll make sure that the 8 will be negative, because when we say 8, negative 8 plus 3, this would give us a minus, a negative 5. So putting these two factors in, we have negative 8 and 3. And the factors of x squared will be x and x, which is equal to 0. Now once we found the factors of 24 that subtracted give us 5, negative 5, now set each piece equal to 0 and solve for x. X plus 3 equals 0. And also this factor, x minus 8 equals 0. Subtract the 3 on both sides, negative 3, negative 3. Positive 3 and negative 3 cancels out. We have x is equal to negative 3. So that's one solution. Now for this one, since we're subtracting from x, we're going to add 8 to both sides of the equation. Negative 8 and positive 8, that gives us 0. And x is equal to 8. So these are our solutions to this equation. Now, for this one, we don't have a C term here. So the technique that we're going to use here is different. What you can see here is that here we have common factors of x. So we'll factor out an x. If we factor out an x, then what's remaining is x plus 5 is equal to 0. Again, we do the same thing. We set each piece equal to 0, which is x is equal to 0, and x plus 5 is equal to 0. This one is already solved for x, so what we need to do is solve this one for x. How do we do that? We subtract 5 from both sides of the equation. Positive 5, negative 5, that's 0, and all we have is x is equal to negative 5. So these are our solutions to this equation. Alright, this one. Notice the difference here. The coefficient here is greater than 1. So we can either do the AC method, or we can see that this is a prime and try to use trial and error. So let's go with the AC method. So the AC method, this is A, this B, and this is C. So we'll take A and times it by C, which is 2 times negative 6, which gives us a negative 12. So now we have to find factors of negative 12 that when we add or subtract it, it would give us a negative 1. So what are these factors? We have 6 times 2, we can call this negative 6, times a positive 2, but this wouldn't give us a negative 1. We also have negative 4 times 3. These two pairs will give us a negative 1. So we have negative 4 plus 3 is equal to negative 1. And that's what we're looking for. So what we're going to do is replace these two factors inside of this equation. So we have 2x squared minus 4x plus 3x minus 6. Now from this point on, we're going to factor by grouping. So we could factor these two terms together, and we could factor these two terms together. So the greatest common factor in these two terms is 2x. We're pulling out 2x, and what is remaining? We have x minus 2. And then in this term, we have a common factor of 3. So we're pulling out a 3. What's remaining? X minus 2. So notice again, now we have common factors here, and we can factor that out. So that'll be x minus 2 times 2x plus 3 is equal to 0. And again, we use the zero product rule and set each piece equal to 0, x minus 2 equals 0, and 2x plus 3 equals 0. Now we solve for x. This is not necessary. So since we're subtracting from x, we'll add 2 to both sides. Negative 2 plus 2, that gives us 0. So what's left on the left-hand side is x is equal to 2. So this is one solution. Now over here, since we're adding to the 2x, we'll subtract 3 from both sides of the equation. Plus 3, negative 3, now we have 0. So what's remaining is 2x is equal to negative 3. Now here, since we're multiplying by 2, to get rid of it, we'll divide by 2. 2 divided by 2 gives us 1, but whatever we do on this side, we must also do on this side of the equation. So x is equal to negative 3 over 2. So these two are our solutions.